Hello, this is Paweł from DevOps Codes Academy. Welcome to our next lesson. Last time we learned about basics of Docker. Today we're gonna write our first Docker file. We're gonna use Python Flask application as an example to build a Docker image and then run it on our computer. So we will be able to reach out one of the endpoints and see in the browser how we can interact with a Docker container. Don't forget to subscribe, leave a thumb up under the video and any comment if you have any questions, and let's jump to the console. All right, we are in the terminal. So I prepared a simple Flask application. This is a Python code. If you are not familiar with Python, don't worry. However, if you have some experience already working with any programming language, you can try to understand what's going on here. I will just tell you that we're gonna expose an endpoint on the root path, and there's a simple function that will return an HTML h1 block with some text, and we are defining that we're gonna listen on port 5000 inside the application. However, we're gonna map it to the port on our host, in my case on my MacBook. So I will show you how this is gonna differ, those ports in a while. You need also a requirements file for Flask application. In my case, it's 2.2.3 at this moment. And I created a new Dockerfile. So Dockerfile is the one that helps us to write the instruction for what we want to build. So in our case, we're gonna use Python, and then we're gonna use tag. And if we are not sure which tag we want to use, let's go and find it. I guess it's 3.11 Alpine. Python images, Docker Hub. You can go take a look. Alpine, of course, if you remember from last lesson, will be a very small one. There are already some 3.12, but let's go 3.11. 3.11. Alpine, and there's such a tag. Great. Okay, we're gonna create a workdir inside the container, and if it doesn't exist, we might need to create that. But let's try with this /app, and this is the root of the image. So first, we're gonna copy our requirements file, and we can copy it into the app. We can explicitly define either we can use a dot here, and we will use dot in a second to show you that all of it should work. And after that, we want to run a command. So in our case, we want to install those requirements. So we can use pip install on the text file. That will install all the dependencies for the Flask application. After that, we want to copy everything, and we can use those dots, right? So here's a source and destination. In our case, we'll copy all other files. We can set up entry point. In our case, that will be a Python, and this will be the first binary run inside the container. And then we can use the command executable. In our case, will be apply, and as long as we are in a workdir, everything will be executing in that workdir, so we don't have to point any path for this file. However, if we would do something like this, it should work as well. Okay, let's try it. So let's docker build, and we have to tag. So let's do our DevOps Codes Academy, let's say Python, and we can specify the tag. So the same like here for the version. If we don't specify it, it will be tagged with latest, but we can do like even v1, right, version 1. And we can specify explicitly the Dockerfile, or we can skip it because Docker will by default use this file, and we have to use the context, and context will be the current directory. The context will say that from where we want to copy our source files. So let's build that. It's not F, but it's R. So let's try to rerun it. Okay, now everything went smooth. And now we can see in our Docker that we have an image, and there are some previous images that I tried 20 minutes ago. And we have a tag v1, and previously I didn't use any, and it was doing latest. But using latest, it will overwrite every time. So you can see that if you build another one, the previous one will be without any tag, right? So it's kind of trash. So it's better to use tags. And now we can use docker run. And we want to map ports. So it's very important to understand that the first port is our host port, and the second one is the port inside the container. So inside container, we are listening on port 5000. And I want to show you that on our computer, we're gonna use port 5001. It's much easier to understand that. And we can run our Docker container. So we allow traffic from all hosts, and we see that it's listening on port 5000. So if we open localhost 5001, you can see that we have a response, and as we are running in the debug mode, we see that there's a 200, right? If we try to go for different path, we have 400, and it's also visible here. One thing that I want to show you right now, so this is our Dockerfile, this is our instruction for the container, but of course we can go inside our container. More actions, not here, that will be containers. Go to the terminal, and we are inside our container. So there's no nano. I can install apk add nano, and we can modify our file from here. Hello from modified DevOps container. We can save this, and if we refresh, you can see that this is live going, right? Because this is debug mode development. So we have everything. But if we stop this container, delete, and run a new one, all these changes will not be persistent. It will always come from the image. But let's give another try. So let's open new terminal here. So we can run parallel, but on different port, second container. And if we go to localhost 5002, you can see that we have an original version. So that's That's the difference here between image and container. But of course, if we go for version 2, we can always stop it. We can always build, and we can make a different tag here. Okay. And then when we run, we can use version 2. Let's refresh here, and we have a version 2. And you can see that we have 2 running containers and 1 is exited. So to prevent that, to do not keep all those containers if you don't want them, when we run, we can also add a flag /rm. Let's see again, and this is 5 seconds ago. That's this one, quizzical greeter. If we stop it, it will be automatically removed, right? So we will not have this trash on our computer. Another thing that we can do here, we can add a name. My container. And you see that there's the name of the container. There's also an ID. We have logs, statistics, many other things that you can discover here. Okay, that's very simple Dockerfile that I want to show you. And of course, we have Docker images. We can see all of our images. Those, they have IDs. We can remove. So Docker RMI. And even you can see some of my old ones, images, it's disappear. We can also do it from the Docker desktop if you're on Windows or on MacBook. So let's do a quickly cleanup. You can make from here, container, delete, images, delete. So for the next lesson, I will prepare a little bit more advanced Docker container, Docker image, and we're gonna try to deploy it on ECS, AWS Elastic Container Service using Fargate, the serverless one. And later on, we're gonna try to set it up behind the load balancer. That will be our backend. And in the end, our goal will be to have a front end on S3 and backend behind load balancer on ECS, together with some RDS database. I want to show you the 3 web tier application. So thank you very much. Don't forget to subscribe, and see you in the next lesson.